All right, so today we're going to continue on in chapter 3. As you can see by what's on the speaker mode view, my page, we're going to start today, and it's actually section 3.6 in our book, but it's comparing strings. And we've done very little work with strings. In fact, in a chapter 2, we jump ahead to chapter 9 to get a little more information on strings. But up to this point, we haven't done a lot with strings. But we do have a data type called string, okay? And I'm creating two variables, name1 and name2. And I'm saying name1 equals Mark. So I'm giving them values right up front for name1 and name2. Now, what did I mean a moment ago? Well, we've done a couple of things like name1 dot char at 0. That was a method that goes along with strings, and it says, hey, take name and get the character that's at, so the char, the character that's at position 0, and what would that give me?
M,
right? That capital M. So yeah, we did char at, and we also did something like name2 dot length. Actually, these are parentheses. Length. And if I say, what's the length of name2, you should be telling me that it is
4.
4, right? And I would have to store this in an integer variable, just like I would be storing this in a character variable, because this results in a char, a character. This results in an int. So we've done a little bit of work with string and some of the methods. If you're ever curious, you could just Google Java it and see what are a lot of these other methods that go along with, with the string class. Right? But for now, we're following up with something that we've done with all of our other data types, and that's this comparison equals. Okay, remember, just one equals is the assignment operator. Well, we have two equals here, so we want to know this is the actual equals. And I want to know if name1 equals name2. And if you look up here, you're going to tell me yes or no.
No.
No, why?
Because everything, it compares it character by character. So when it gets to Y and K, Y is actually greater than K. So it would say Mary is actually greater than Mark.
Excellent guess, but wrong. Okay. Now I set you up, Chad, a little bit, but here's what it's actually doing. When I create a string variable, right, called name1, I don't know how long that's going to be. I mean, it could be the name Mark, it could be Mississippi, it could be one fat hen, a couple of ducks, 3 brown. It's huge. In fact, there's something invisible that you don't see that appears at the end of the string so that it knows when to stop. So the way a string variable works is when I say string name1, what I get in name1 is just an address. And that address goes to a memory location and sees capital M, A, R, K, and then the delimiter /0 so that it knows that it ends. When I created string name2, again, name2 was an address. And over at that address, starting at the beginning, it's M, A, R, Y, and then an invisible /0 that you never see. So when I say if name1 is equal to name2, what's actually being compared? The addresses. So the answer here is going to be no. Okay, these aren't going to be equal because they have different addresses. Like I said, I set you up because you did exactly what I wanted you to do. You compared the M's, the A's, the R's, each individual character at a time.
Yeah, I think I was thinking of the compared to.
Okay, yeah, the compared to is around. One that we're going to use. Now, if I want to know if one string equals another, I'm going to use what you had in code listing 9, where I say something along the line of if name1 dot equals name2. So this is a method that's written, just like we had methods up here. We passed a 0 in so it knew which location. Here we're passing another string in, and it's going to say take each individual character of name1, compare it to name 2, and see if they come out equals. And if it does, it's going to give me a result of a Boolean. So I might want to use this possibly in an if statement. If name 1 dot equals name 2. So that's one of the things we want to be careful with. We're in this chapter where we're learning about our logical operators, because this was one of the logical operators. Less than, greater than, less than or equal to, greater than or equal to, equals to, and not equals to. So we need to draw special attention to this. And for the author to make it an entire section, it's pretty important. Okay, and again, this guy, string name 1, says, give name 1 a starting address where I'm going to store a string. It's kind of funky how that works. Back in the old days, this didn't exist. We had to use something called a character array. So it's made a little bit easier for you all, and that's the way comparisons of string is going to work. The dot equals does the individual comparisons for us. Questions? Okay. The next section, and I put this as extra for experts. So if you're struggling right now and you're not feeling caught up or anything, okay, great, because a lot of you only need one comp-sci course. Some of you are sticking around for 4 semesters or 4 courses or more if you have to repeat any, which is fine. This is a section that's in the book. And in the summer, I go to Kansas City to grade the high school AP test. And the high school AP test, some of you may not know, is in Java. So if you pass the high school AP test, that's why our first class is Java. We give you credit for it. But if you take a look at this, this is something that's kind of common that students will use. And it's pretty funky. It starts out and it takes this statement inside and says, if x is less than 0, that's my question. If x is less than 0, if it is and it's true, then y gets a value of 10. Otherwise, y gets a value of 20. So and what I would rather see and what I would probably do is this old school, if x is less than 0, y equals 10, else y equals 20. But there's a way to use this conditional operator to take those 4 lines and make it just one line. Hardly ever get any students that use this, but I'm just throwing it out there again, extra for experts. It's an optional type of thing, but I wanted to point it out. Any questions so far? Feeling pretty good? Excellent. All right, something that becomes big for us, and that's this thing called a switch statement. And in our book, we're up at section 3.9. This is going back to replacing the if statements, writing something that I could do with an if statement if I really wanted to, but this switch statement is something that's a little more organized. Okay, so this again is section 3.9. If you're taking notes in your book, a lot of you are just taking hand notes here. But a switch statement, and again, you typed up code listing 13 and 14, so you have a little bit of an idea. Well, most of you, I think I saw 17 out of 21 did the code listings this time. But anyhow, I still think they're invaluable before class starts to already have these done. So a switch statement is going to start out with the word switch, and it's going to be enclosed, its body is going to be enclosed in a left brace and a right brace. So everything inside of here is a left brace and a right brace. The thing that follows the switch actually has a name. It's called a case selector. Okay, this case selector needs to be an ordinal value. There's a few times we can get away with it, like for a string, but an ordinal value has a unique successor and a unique predecessor. For example, in the world of integers, if I say 6, what comes before the 6?
5.
5. What comes after the 6?
7.
Good. If I say in the character world, lowercase b, what character comes before it?
Lowercase a.
Yeah, and after it?
Lowercase c.
Yep. True. What comes before true? Starts with an F.
False.
Yeah. What comes after true? False. Okay. False. It wraps around. True is a 1. What comes before 1 clearly is a 0. But what comes after 1, well, in a byte, it wraps around and comes back around to false. Okay. What about the number 4.16? What comes before it?
4.15.
Guess again.
316.
Nope. We don't
False.
know. Okay. So when we come back up here, it has a unique one. We don't know if it's 4.15. We don't know if it's 4.159. We don't know if it's 4.1599999 or what comes after. So as far as what an ordinal data type is, int is yes, char is no, boolean is yes, and so on. We can also use strings up here if we wanted to. So up in this switch statement, we're going to have a variable. Could be an expression, but not too often. And the variable could be, let's see, quiz grade, right? Q grade. You just took a quiz and you got a grade from 0 to 10. Okay, so this is an integer. So that means if I come in here, I'm going to start looking for case labels. Now, my first case label might be a 10. Nice job, right? And then inside of here, I have the body for this case. I could put a bunch of statements. Now, you see this one right here, the break. Where do I go when I hit the break?
Outside of the switch.
Right, past this brace. It jumps me out, just like an if statement would, right? Well, some of you have learned, what if this break, I don't see a break. What if that break wasn't there? What would it keep doing?
Jump to the next case.
Yeah, and it's going to keep going down through the next case, and it's going to keep dribbling down until it sees a break. So breaks aren't required, but we want them most of the time because we want to be able to break out. So I might have the case label of 10 inside of here, system.out.print, you did a great job. That's an A, perfect score, whatever, whatever. I might have a case of 9, you know, hey, you got an A, and break out. And then finally, I have this default, sort of like that last else and an else if. If it's not a 10, if it's not a 9, it's going to come into this default. Again, the default is optional. We don't have to have a default. So when we're looking at examples of this, what we can put in, you know, I could even do, and I think, oh, here's what I want you to do. I want you to go Google Java switch statements real quick. Okay, so we just looked at some examples online on Google. We did a quick search and we saw a bunch of examples of a switch statement. So now what I want you to do is I want you to write a program called roulette points or somehow. So here's what's happening. When you go to the register at Sheets and they hit a button and you're going to get a random number from 0 to 99. Now, if you get the numbers 0 through 9, you get a free French fry. If you get a number between 10 and 19, you get a free drink. 20 and 39, you get a free 6-inch sub. 40 to 59, you get a fancy coffee. Otherwise, numbers 60 to 100, you don't win anything. All right, so you're going to randomly generate these numbers. Now, how in the heck am I going to put all 20 in here? 40, 41, 42, 43, 44, 45, all the way up to 59. Well, that's a little trickery that hopefully someone in your group of 3 is going to help you figure out. But I did put a hint here. Use mod. Okay, use mod. And that's going to give you a little bit of an idea of what to do for a case. So we're practicing a case problem. You're going to get a random number to start, and then you're going to equate those random numbers over here. You're the programmer. Think outside the box a little bit for this one.